Hello friends, this is your friend Rahul. Welcome you to this video. Today we will discuss the last topic of this chapter. We will learn about the lens formula, magnification and power of the lens. We have already learnt a lot about mirrors and lenses, such as how mirrors reflect and lenses refract. Mirrors and lenses have some similarities as well as differences. If you remember, we have learnt a mirror formula too. Just as the mirror formula shows the relationship between object distance, image distance and focal length, similarly, the lens formula also shows the relationship between these three parameters. For any lens, the lens formula looks like this. Like the mirror formula, lens formula too have 5 sign conventions. Number 1. In the case of lenses, all the distances are taken from O, which is known as the optical center of the lens. Number 2. The object is always placed on the left side of the O, as it was used to be in mirror formula too. Number 3. Distances on the left side of the O are always taken negative but positive on the right side. Number 4. All the distances above the principal axis are taken as positive and all the distances below the principal axis are taken as negative. Number 5. Focal length of convex lens is taken as positive, but for concave lens it is negative. In the case of a mirror, it was clear that in a convex mirror, the focus is on the right side, so it is taken positive, and in the concave mirror on the left side, so it is negative. But the lens has 2 focuses, so how will we give the symbol? This point can be understood here. Convex lens converges the light coming. We know that convex lens after refraction converges the light on the focus, which is on the right side of the lens. This focus acts the principal focus in case of convex lens. Hence, the focal length is taken positive. Conversely, in the case of a concave lens, the light after refraction appears to be diverged from the focus, which is on the left side of the lens. Hence, the focal length is taken negative in this case. With the lens formula, there is another property which we know by the name of magnification. Like in case of a mirror, it is the ratio of the height of the image to the height of the object, which indicates how large or small the image is compared to the object. This mathematical relation shows the magnification of the lens. It can also be represented in the form of the ratio of image distance to object distance. Let's move towards the next part of the video. You must have noticed people find it difficult to see distant or nearby objects clearly. To these people, doctors suggest wearing eyeglasses. We must have heard from our friends who wear eyeglasses that the power of their eyeglasses are 2 or minus 1.5. What does this power mean? And how do these eyeglasses are made? We will get to know the answers to these questions in this part of the video. This is nothing but the power of the lens. This power signifies the ability of the lens to converge or diverge the light. It can be represented mathematically as the reciprocal of the focal length. The SI unit of the power is diopter, which is denoted by D. 1D is equal to 1 meter inverse. We know that the focal length of a convex lens is positive, so the power of a convex lens is also positive. In contrast to the focal distance of a concave lens being negative, its power is also negative. And this is the reason that the power of the lens applied in the glasses is also positive and negative, which we will know in detail in the next chapter. Here this chapter ends. We will meet somewhere in the future. I would suggest you show these videos to your friends as well, because I believe knowledge is power and sharing is caring. Bye friends, take care.